Students, this is plus 2 mathematics, chapter 4, inverse of trigonometric function. Now we are going to study about the tan and tan inverse of function, right? Before we enter into this topic, we want to find out the trigonometric table values, right? You see x is 0 degree, 30 degree, 42 degree, 60 degree, 90 degree and 180 degree. So 30 degree is nothing but 5 by 6, 45 is nothing but 5 by 4. And 60 degree nothing but 5 by 3, 90 degree nothing but 5 by 2, pi is 180 degree. What is the expected value tan x? 0, 1 by root 3, 1, root 3, 8, 0. These are the trigonometric table values. Now, consider tan x. But your tan x is not 1 to 1 and 1 to for entire value. But we want to find out the inverse of function means the function should be a bijective. What is bijective? 1 to 1 and R2. So, in particular domain, that means that particular domain is nothing but a restricted domain, right? So, minus 5 by 2 plus 5 by 2, this is the restricted domain. Then tan inverse of x, tan x both are what? Inverse, that means bijective, 1 to 1 and R2. This particular minus 5 by 2 plus 5 by 2, this restricted domain is nothing but a principal domain. So this is the domain. So then what about the range? Minus infinity to plus infinity. That is nothing but principal values. This minus infinity to plus infinity, nothing but R. R, nothing but real numbers. So real numbers means minus infinity to plus infinity. In tan x, the domain value is minus 5 by 2 plus 5 by 2. This one, the range value is nothing but minus infinity to plus infinity. So this is nothing but domain and this is nothing but range. But in inverse of this function, it will be domain and range will be interchanged here. So this is nothing but domain for tan inverse of function, okay? And this tan inverse x otherwise known as all tan, right? This is nothing but range, okay? So domain minus infinity to plus infinity, range is equal to minus 5 by 2 plus 5 by 2. These are tan x and tan inverse of definition of tan x and definition of tan inverse x, the respective domain and range. Now, what is the properties of function? You see, y is equal to tan inverse of x. This symbol is nothing but if and only if. Okay? So, we can write like this also. IFF. If and only if. Y is equal to tan inverse of x. We can write x is equal to tan y. Then what is the placement of x? The placement of x is nothing but real number, that is a minus infinity to plus infinity, and y is nothing but the power of minus pi by 2 to plus pi by 2. Then tan inverse of x is nothing but what? X if x belongs to R. Here this tan x is nothing but odd function. You know very well odd function. F of minus x is equal to minus f of x means odd function. Next step, third point. Tan inverse of tan x is equal to x if and only if here x belongs to minus 5 by 2 plus 5 by 2. You see the changes here. This is the function tan, okay? Here tan inverse of x. So it will be changed, but the results are only same. Here tan inverse of x means x belongs to R. Here tan inverse of tan x means x belongs to minus 5 by 2 plus 5 by 2. Keep it in mind. Now, what is the graph of tan x and tan inverse of x? So, now we have to draw the graph of tan x. So, it separately will be asking questions in exams also. So, y is equal to tan x. Now, we will very well. So, the table value 0, 1 and 0. Okay, I took only this particular interval minus 5 by 2 plus 5 by 2 because this is principal domain, restricted domain. So, we want to concentrate only minus 5 by 2 plus 5 by 2. And the values, so leaving this values, take 0, 1 and infinity. So these are the three values, okay? So 0, pi by 4, pi by 2 means 0, 1, infinity. So let's say means it will become additive also, okay? So this is minus infinity. So what is it now? 220 points, x is equal to minus 5 by 2 means tan of minus 5 by 2 is nothing but minus infinity. So we can plot the points minus 5 by 2 comma minus infinity. And x means minus 5 by 4 means y will become minus 1. And x is 0 means y also 0. And x is 5 by 4 means y value is nothing but 1. And x 5 by 2 means y value is nothing but infinity. So this is the infinity, so we want to draw a line at x is equal to pi by 2 as well as minus pi by 2. Now look at the point, minus pi by 2 minus infinity. We can't mark it the point because infinity means there is no values, not defined values. But look at these 3 points. Just to mark the points, minus pi by 4, minus 1, the point is here, and 0, 0 is here. Minus pi by 4, 1 means the point is here. Then this pi by 2, x is equal to minus pi by 2 and x is equal to plus pi by 2 is an asymptote. Asymptote means tangent. The point of contact at infinity. Asymptote means nothing but a tangent line, but we can't say this is a point of contact. We can't define the point of contact. Hence, the tangent line is nothing but asymptotic lines. So, this x is equal to 5 by 2 as well as x is equal to minus 5 by 2 act as a asymptote of the function. Now, so the graph be like this. This is nothing but tan x. This is nothing but y is equal to tan x. Now, we want to find out the value of tan inverse of x. Just want to take the reciprocal. X treated as y treated as x. Look at here. So, this is the graph of that for the same function. But here, x minus y values will carry over. We get 1 into another one. So, this is the particular table. Here x values, y values will be interchanged. That's all. Now I want to find, draw the graph. So first of all, you want to draw pi by 2 asymptotic lines. Y is equal to pi by 2. So this is y is equal to pi by 2, and this one is y is equal to minus pi by 2. The same way here, minus 1 minus pi by 4. Here 0 to 0 comma 0. Here 1 comma 5 by 4. Here minus 1 comma minus 5 by 4. Sorry, and this one is 0 comma 0, and this one is 1 comma 5 by 4. Now, what is the graph look like here? This is asymptotic line, so it starts from this one and goes on this one. But it's not edges. It's at tangent line, so but the point of contact we don't know, so it should be an infinity, right? So this is tan inverse of x. Now the tan inverse of x is symmetric about origin. Tan inverse of x symmetric about origin. Tan inverse of function only continues in the interval of minus pi by 2 to open interval of minus pi by 2 plus pi by 2. So it's symmetric about origin and it is odd function too. The period of tan x is nothing but pi. Okay? Thank you. Next one, this is example 4.8. Find the principal value of tan inverse of root 3. Okay? No solution. Take the given question as y, where the y is equal to tan inverse of root 3. So tan inverse of y, tan inverse of root 3 we can write like this, tan y, which is equal to root 3. So, we know very well, tan 60 degree, tan pi by 3 is nothing but root 3. So we can equate this one. So y is equal to pi by 3, which is this pi by 3 is belongs to the open interval of minus pi by 2 plus pi by 2. Because pi by 3 is nothing but 60 degree. So 60 degree lies between minus 90 degree to plus 90 degree, right? So y is equal to pi by 3. That is tan inverse of root 3, which is equal to pi by 3. The same question, but the minus sign here for the next one. Okay? You see, example 4.9, find the value of tan inverse of minus root 3. That's it. Solution. The first one solution, where the y which is equal to tan inverse of minus root 3. So take the tan inverse to the left side, it will be tan y. So tan y which is equal to minus root 3. So this is nothing but minus pi by 2, right? So otherwise we can write like this, minus tan pi by 3, because minus for minus, tan pi by 3 is nothing but root 3, and this minus tan theta, we can write tan of minus theta, because tan is what function? Odd function. Tan is odd function. So we can write like this, tan of minus 5 degree. So tan y, which is equal to tan of minus 5 degree, then y is equal to minus 5 degree. This is the tan inverse of minus root 3, which is equal to minus 5 degree. Next, we have to go for tan inverse of tan of 3 sine 4. Okay, I wrote this one. Now question number 2. Tan inverse of tan of 3 pi by 5. But we have the result. We know that tan inverse of tan x, which is equal to x, if x belongs to open interval of minus pi by 2 plus pi by 2. We can write tan inverse of tan x, which is nothing but x, when that x belongs to minus pi by 2 plus pi by 2. You see, here 3 pi by 5 not belongs to minus pi by 2 plus pi by 2. Why? You know, just given pi is nothing but 180. So 180 divided by 5. This is nothing but 5 by 5. So cancelling this one, you get 36 degree. So 3 pi by 5 means 3 into 36 degree. So 3 into 36 nothing but 180 degree. So 180 degree not belongs to minus 92 plus 90. Right? So we can't use this formula directly. Right? So now you see tan inverse of 3 pi by 5, I can write tan inverse of so we can write pi minus, okay, pi minus, you see one more result here, tan of pi minus theta, tan of pi minus theta according to the rule A, S, T, C, this is a pi minus theta, this is nothing but pi plus theta. So pi minus theta lies in the second quarter, the placement of sin theta and the cosine theta only positive. So tan of minus theta is nothing but minus tan theta. But we are applying minus here, tan of pi minus theta which is equal to tan theta. Tan is a odd function, so we can take it inside the minus sign, we take it inside means it will become tan of theta minus pi, which is equal to tan theta. Now we are using the relation, right? Now you see tan of theta, so tan theta, we can write tan of theta. What is theta here? 3 pi by 5 minus 5. Okay, so tan theta, we can write tan of theta minus 5. So now it is simplified this one. So tan inverse of tan of cross multiply 3 pi, this one pi, so 3 pi minus 5 pi, that is nothing but minus 2 pi here. So tan inverse of tan of minus 2 pi, 3 pi minus 5 pi minus 2 pi divided by 5. So this is nothing but minus 2 pi by 5 because of the result. Tan inverse of tan of x is equal to x when this x belongs to minus pi by 2 plus pi by 2. Now you see minus 2 pi by 5. So minus 2 pi by 5 belongs to in the interval of open interval of minus pi by 2 plus pi by 2. So the entire value, okay, that's the entire value tan inverse of tan of 3 pi divided by 5, which is equal to minus 2 pi by 5. Okay, next question number 3. Question number 3. Tan inverse of 2000. So we have a result. We know that tan inverse of x is nothing but x if x belongs to R. We can write tan inverse of x is nothing but x if x belongs to R. Since Here 2019 belongs to R means what? Minus infinity plus infinity is a number line. So 2019 became what is. So it belongs to R. So simply we can write tan inverse of 2018 is equal to 2018. Since that is 2018 belongs to R. Thank you. Hi students, this is example 10. Find the value of tan inverse of minus 1 plus cos inverse of 1 by 2 plus sin inverse of minus 1. Now we want to find the initial value, then you are going to add it. You get the exact number. Okay? Now solution. Tan inverse of minus 1. We know very well tan pi by 4. Tan pi by 4 which is equal to 1. So tan of minus pi by 4 which is equal to minus 1. So now exact value. So minus 1 is nothing but that means tan inverse of minus 1 nothing but minus pi by 4. So this is nothing but minus pi by 4. And cos inverse of 1 by 2 is cos pi by 3 is nothing but 1 by 2. So now we take pi by 2 means cos inverse of 1 by 2, right? So cos inverse of 1 by 2 is nothing but pi by 3. Next one, sin inverse of minus 1 by 2. Okay, now sin of 1 by 2, that means sin 30 pi by 6 which is equal to 1 by 2. So sin of minus pi by 6 means minus 1 by 2. So minus pi by 6 means sin inverse of, this sin inverse of minus 1 by 2. So sin inverse of minus 1 by 2 is equal to minus pi by 6. So now easily find that. Now we want to add. Therefore, tan inverse of minus 1 plus cos inverse of half plus sin inverse of minus half which is equal to minus pi by 4 plus pi by 3 and minus pi by 6. So now taking LCM will reach 1. Okay? So 4, you want to multiply with 3, so minus 3 pi. Here 3, you want to multiply 3 4 is 12, you want to multiply with 4, so 4 pi. Here 6 2 is 12, so you want to multiply with 2, then 2 pi. So minus 3 pi, minus 2 pi, symbols are same, so you want to add it. So minus 5 pi, minus 5 pi, then plus 4 pi divided by 12 which is equal to minus pi divided by 12 which is belongs to the equation of minus pi by 2 plus pi by 2. That's all. Hi students, this is example 11. Prove that tan of sin inverse of x is equal to x divided by root of 1 minus x square within the interval minus 1 less than x less than 1. Okay, within the interval we have to prove that x is equal to RHS. So I am going to put this up like 3 cases, right? So this is number 1, you know, so minus 1, 0 and plus 1. I am taking the interval, so minus 1 to 0, one interval, 0 to 1 is another interval, exactly 0 is a third case, okay? Case 1 minus 1 to 0, case 2 0 and the third one is 0 to 1, like the 3 cases. Now for the solution, I took first step. X is equal to 0. What about the left side? So tan of sin inverse of x is equal to tan of sin inverse of 0. Sin inverse of 0 is nothing but 0. So tan 0. Tan 0 is nothing but 0. Next you want to take the right side. So x divided by root of 1 minus x square which is nothing but 0 because of x is equal to 0. And the root of 1 minus 0 square, this is nothing but 0 by 1. Square root of 1, that is nothing but 0 by 1 which is equal to 0. So tan of sin inverse of x is equal to 0, x divided by root of 1 minus x square also 0. So these two are equal means this side also equal, implies tan of sin inverse of x which is equal to x divided by root of 1 minus x square. This is proof for x is equal to 0. Next, I am going to take the interval minus 1 to 0. This is case 2. Case 2, I am going to take the interval minus 1 less than x less than 0. Right? Now, I want to assign that sin inverse of x is nothing but theta. Where theta lies theta lies 0 minus pi by 2 0 minus pi by 2 less than theta less than 0. Now sin inverse of x is equal to theta. Then what about sin theta? That is nothing equal to x. So sin theta is equal to x. But sin theta we can write. So now I want to consider the right hand triangle here. Whether theta is an angle, there is an acute angle. This is right angle 90 degree here. So sin theta we can write opposite by hypotenuse. So this is theta, hence it is opposite side, and this one is the hypotenuse side, and this one is adjacent side. Now, what is opposite side? X. Because x by 1. X can be written as x by 1. What is the hypotenuse side? 1. Now we have to find out adjacent side. What is adjacent side? So we know the Pythagoras concept. Adjacent side square, we can write hypotenuse side square minus opposite side square. Okay? What is hypotenuse side square? The right should be 1. So 1 square minus x square, which is equal to adjacent side square. So I need adjacent only. So I want to take square root. So 1 minus x square. So this is nothing but root of 1 minus x square. This is sin theta. Sin theta is equal to x by 1. So implies I can write tan theta. So tan theta is nothing but opposite side divided by adjacent. What is opposite side? Opposite side is nothing but x. What is adjacent? This is nothing but 1 minus x square. Root of 1 minus x square. So now this theta is nothing but sin inverse of x. So in theta we want to substitute sin inverse of x. We get tan of sin inverse of x, which is equal to x divided by root of 1 minus x square. So this case over. So put it this is 2 and this one is a 1. Okay? This is 2. Now case 3. Now consider the interval 0 to 1. This is the max. This is the interval 1. So minus 1, 0, 1. So now the third interval. Okay, case 1. So interval 0 less than x less than 1. Direction again theta, which is equal to sin inverse of x, where here theta lies 0 to plus pi by 2. Okay, 0 to pi by 2. Again we can write sin theta here. Sin theta is equal to x. X going to write x by 1, which is nothing but opposite side divided by hypotenuse. So the same way we can write tan theta also. So tan theta is nothing but the same concept we want to follow here. X divided by, that is opposite side divided by adjacent side. This is nothing but x divided by root of 1 minus x square. Again this theta is nothing but sin inverse of x. So tan of sin inverse of x, which is equal to x divided by root of 1 minus x square. This is 3. So from 1, 2 and 3 in 3 equations we get tan of sin inverse of x, which is equal to x divided by root of 1 minus x square in all the cases, that is minus 1 less than x less than 1. So in minus 1 less than x less than 1 we can prove tan of sin inverse of x, which is equal to x divided by root of 1 minus x square. Thank you. Hi students, this is exercise 4.3. Find the domain of the following function. So question number 1. So given function is nothing but tan inverse of root of 9 minus x squared. First of all, we have to recall what is the definition of tan inverse of x. So the tan inverse of x is defined from minus infinity to plus infinity to minus pi by 2 plus pi by 2. This is nothing but tan inverse of x. So minus infinity to plus infinity is simply known as r. Okay, capital R. Means real numbers. So R2 minus infinity, open interval of minus pi by 2 to plus pi by 2. Now this is a domain, right? So in case 9 minus x square, root of 9 minus x square within the interval minus infinity to plus infinity. But in real numbers, the functions exist in the root, so therefore it always greater or equal to 0. Okay, so because we are getting square root of negative value, we get complex number, I will come, right? So I will root of, for example, root of 4 minus 4 means we can write plus or minus 2 into I. So it is not belongs to R. So given function in root, so this root always greater than or equal to 0 because of the root function, right? Now square on both sides, so you get 9 minus x square greater than or equal to 0. So taking to that side, 9 minus x square goes to that side plus. So 9 greater than or equal to x square. Now just to change it, x square less than or equal to 9. See, 9 is bigger. Okay, 9 is big, x square is small, so x square is small and 9 is big. Now what about x? X is equal to less than or equal to 3. Take otherwise mod x is equal to less than or equal to 3. It seems that x varies from minus 3 less than or equal to x plus 3. Minus 3 less than or equal to x less than or equal to 3. That is nothing but x belongs to the closed interval of minus 3 plus 3. That's all. Next question about 1 by 2 tan inverse of 1 minus x square minus 5 by 4. So these are too simple. First of all, we want to take the tan inverse of function. So tan inverse of function is defined from R2 minus 5 by 2 plus 5 by 2. Here consider the only x terms. So this 1 minus x square belongs to R. 1 minus x square belongs to R. It simply seems that x belongs to R. Whatever it may be, that is x belongs to R. So what is the domain here? Therefore, the domain is nothing but what? R. Simply you can say R because x belongs to R. As well, this is the exercise 4.3 question number 2. Find the value of tan inverse of tan of 5 by 4. Okay, so we have one result that is tan inverse of tan x is nothing but x if and only if x belongs to in the interval of minus 5 by 2 plus 5 by 2. Here 5 pi by 4 not belongs to in the interval of minus 5 by 2 plus 5 by 2. So need some calculation here. Now what is the question? Tan inverse of tan of 5 pi by 4. We can write tan inverse of tan of 5 plus 5 by 4. We can write tan of 5 by 2. You see 5 plus 5 by 4. This is nothing but tan inverse of tan of 5 by 4 because tan 180 plus theta which is equal to tan theta. Which quadrant? This is third quadrant. Tan lies in the third quadrant. ASDC. So this is pi. 180 plus theta means tan theta. Right? So this is nothing but pi by 4. Since that pi by 4 belongs to the interval of minus pi by 2 plus pi by 2. Therefore, tan inverse of tan of 5 pi by 4 which is equal to pi by 4. Now I want to go for the second question. Right? The same concept we want to follow here. Tan inverse of tan x which is equal to x if only if x belongs to the interval of minus pi by 2 plus pi by 2. Here the angle is minus pi by 6. So this minus pi by 6 belongs to the interval of minus pi by 2 plus pi by 2. Hence tan inverse of tan of minus pi by 6 which is equal to minus pi by 6. That's it.